2.5. Alright, so now I need, on my t-distribution, I go down 17 degrees of freedom and go across 0.025. What's the t-value? How much?
2.11.
2.11?
Mm-hmm.
Fair enough. Negative 2.11? Everyone okay with how we got there?
Yeah.
2.11, negative 2.11?
Yeah.
Alright, what we need now is a test statistic. Alright, so our t-stat equals slope coefficient 3.606 minus 0. How different is that from 0? Well, the real question is how many standard errors of difference that is. What is the standard error of the sampling distribution of the sample slope?
1.378.
Everyone see where he gets that? Yeah, 1.378. What does our t-stat come out to? Okay, 2.616, let's plot it. Looks to me, it lands right here's 2.11. Looks to me like it lands right here. T stat equals 2.616. What is our decision? We reject the null hypothesis and we assume the alternative hypothesis. So just to be scientific, we said let's assume there's no correlation unless we have overwhelming evidence to the contrary. We do. We rejected that and we found that there's overwhelming evidence that in fact there is a correlation between field goal percentage and win-loss percentage. And we're just about ready to go tell a bunch of coaches that if you increase your field goal percentage by 1 unit, you could increase your win-loss percentage by 3.6%. So buy my protein supplements and sign up for consulting with me. Alright, so we did a hypothesis test for this. It passed. What if we were to do a hypothesis test for turnovers per game? What would the end result be? Actually, let me back up a minute. Sorry. Back to why we started this. I want to know the p-value of this test statistic. So if it is true that there's no relationship between field goal percentage and win-loss percentage, what is the probability of this sample outcome?
1.8.
Yep, 1.8%. Fantastic. That's extremely unlikely, or very unlikely. It fits our definition of very unlikely. So we're confident.
How do you get it?
We have 1.8 on the.
That's how do you get it? Is that what you want to do?
Yeah, you look on the chart. You could also look on your t-distribution under 17 degrees of freedom,
Yeah.
just to get an estimate
For the p-value?
for the p-value. Yeah. I remember we did the same thing last week. The t-distribution would just give you an estimate.
Yeah.
You would say it would be between these two. So I guess it would be between. So for this t-distribution, it's going to be between 1 and 2.5, right? Because it's 1.8. So if you look under 17 degrees of freedom, you see a p-value of 1.8, or you see a t-stat of 2.6, excuse me. So you look for 2.6, and you say that's going to be. That's going to be between 1% and, it's going to be between 1% and 0.5% for a two-tailed test. So that would mean it would be between 1% and 2%. So you would double it. So you double the 0.5%, double the 1%. So you're able to determine just by looking on this table, it would be between 1% and 2%. Joanne, are you with me?
Yeah, I'm just thinking I might use a calculator or p-value calculator.
Or just look at this.
Most of the time it will be given to us.
Just use this.
I know, but
Yeah,
I
just
didn't know
use
if you
this.
were gonna ask us to do
The only time I would make you calculate the p-value is if you had a z-table.
Okay,
But this, you can't use z-tables for this.
okay. Solve.
Alright. Alright, so tell me about how confident you are that we can infer that there is a statistically significant relationship in the whole population for field goal percentage and turnovers per game. Which one are you more confident of?
Field goal.
Which one are you more confident there is a statistically significant relationship?
Field goal.
Field goal is correct, right? Because it has a lower p-value. Lower p-value means more confident that there is a statistically significant relationship. Now this one, turnover, tell me about the turnovers per game p-value. What do you think about that? Alright, well, what is it, first of all? 4.8%. Would it pass, what would be the hypothesis test decision? Would it pass the hypothesis test?
Yes.
Yeah. So what would the interpretation be for a hypothesis test? Roxanne? Pass, you are correct. It would pass a hypothesis test. So we would say it is statistically significant because it's lower than 5%, but just barely.
Yeah, so I thought that we were going to reject it because it is 4.8. Would we not round up?
No,
No,
No.
just,
reject.
Just-
Yeah, so we reject the null hypothesis that there's no relationship, and we say, yes, there is a relationship. But we were a little shaky on it, because it's just barely under 5%. Okay. Now, alright, so we went over p-values, hypothesis test, we went over confidence intervals, all the good stuff. Alright, now let me get back to this issue of multicollinearity. What does multicollinearity mean?
Means when two variables are very similar to each other. Two independent.
The relationship between the
Yeah.
two.
the correlation among independent.
Yes, the independent variables are correlated with each other. Do you two think these two independent variables, field goal percentage and turnovers per game, are correlated with each other? I think, a quick time check here. Alright. Yeah, maybe someone who plays basketball, make the argument for yes, they are correlated with each other.
Yeah,
Yeah, tell me why they would be correlated with each other.
because you can have a turnover but miss the field goal.
Alright,
If
so,
you're constantly turning the ball over, then you don't have any chance to make field goals, to make goals, so.
yeah, alright, so if you're constantly turning over your, yeah, and that's what
You
you
don't have
said, right?
any chance to
That's
score
kind of what
any
you said,
points.
yeah, alright. So if you're constantly turning over the ball, then your field goal percentage is gonna be low. So teams with high turnover per game would have a low,
Well, you can't
Field
say that. If you're turning the ball over more, the other team has more of a chance to score rather than your field goal is lower.
yeah, that's a good point.
Your field goal is whether you hit or miss.
Yeah,
The turnover is
Yeah.
whether or not the other
Yeah.
team has more of a chance
They
to
can,
hit the
so
ball.
you get-
they can turn the
That's
ball
why,
over.
are they not independent and truly not correlated?
okay, the Tang's argument is, I can't argue with it, but I could still make a good argument that they're correlated. Tang is correct, because he's saying you take fewer shots, right, and then maybe you just happen to hit the shots that you take.
Yeah,
And then your field goal percentage is actually
Yeah.
higher.
Right.
That's
yeah.
So why you make fewer shots? I mean,
If you're always turning the ball over and you make, let's say you only do 3 shots in the whole game, but you make all 3, your percentage is
You're
still gonna be
100%.
high because you got
Yeah.
3 out of 3, so it
Yeah.
really doesn't work.
And the other team makes 5 shots.
We can choose
and
another
five
And they only
shots.
make 1, then there's a little,
We can choose another sport.
Yeah.
The whole field goal thing is confusing me, because that's football, that's not basketball.
That's
So
basketball.
that's so thrown off.
You're thinking about kicking the
Yeah, I'm
field
like,
goal.
field goal.
Okay. Alright, so let me just, for argument's sake, suppose they are correlated with each other. Here's maybe a rationale. A team that practices a lot has a low turnovers per game and a high field goal percentage.
Yeah.
A team that's not very good or doesn't practice a lot has a high turnovers per game and low field goal percentage.
Right.
So these two things might be correlated with each other. So if they are, what did I say we need to be aware of with these t-tests? What I said with the t-test is we can't rely as much on the t-tests.
Oh, we have to do the
We're
F
only
test.
testing individual.
When we're testing individual, we run them separately, but just looking at this, the t-test with the multiple regression, we can't rely as much on these. We are likely to see higher standard errors, larger confidence intervals, higher p-values. And that might cause us to say, wait a minute, these are not as statistically significant as we might think.
So we do that.
So we need a test that gives us the overall significance of the whole model, and that's going to be the F test. And these two things, this F and this significance F, that's going to tell us the overall significance of the model. And we'll do this in 2 steps. First, we'll look at the F test and F significance and say, is there correlation somewhere? Is there predictive ability, explanatory ability anywhere in any of these independent variables? And it turns out that if we have a really high F stat and a really low significance F, this is like a p-value for F. And if this is really low, then we say, yes, we've got something significant somewhere in the whole model. And then we can be a little more forgiving when we look at these p-values and say, well, they're close, they're not really, as low as we would like. We can be a little bit more forgiving if we have this information about the F test and say, yes, there is something significant in the whole model. All right, so how are we doing? Do we want to take a break?
Yes, we'll break.
Yeah? Okay, yeah, let's come back at 8. 8 o'clock? All right, I will see you then.
Oh, okay, I had Two more weeks, guys.
Yeah, for you.
Well,
We got 20 more weeks.
But you know what?
Yeah, I was literally
Put it in the
dreaming.
beginning, yeah.
I dream, yeah.
You made it all the way up to a dream.
And the professional bank on the top.
Real time and like predictive analytics, or predictive data. So real time data, like what that means, and predictive data, like what that means. And then he said, could you identify key customer segments? So the key customer segments were, like in a hotel, and then in the airline, it would be like, right, platinum, it would be the same thing with the seating. Right, based on the miles.
How did it go? I mean, it's similar enough.
And then that goes in hand with customer
One number
loyalty.
off, maybe.
And then streamline market efforts.
Oh, yeah. Go back. Delete it.
have to include the
So
labels.
this is what I have wrote down,
I'm gonna show you what you.
for the airlines, I have put it together there. I guess afterwards, I don't know if
Click on, click on.
but, you know, I guess we could like go through it. I say like trying not to go. You did? What time are you doing? Oh, yeah, class yesterday.
You see how you click on.
You look like you're tired right now.
Yeah, click on the top. Because we click on. the
From where,
labels.
here? And I could hear. I heard something, yeah. So, I don't know.
I just did my other. Once I include the labels. Did you double check on the data input? Double check on the data to see if that's. Once I put on the top labels, then it comes up.
So I was asking him, I was like, you know, I'm trying not to sound wrong, but I was like, well, what, I said, do you have a database? Like, he was like, I don't know, like, I said,
Into the Excel environment.
but, okay, so if you have an app, right, you get data from the app,
Calculate the,
right, on the back end. So they don't have a database per se, but they're getting data, so I was like, well,
sure if I haven't
I guess
submitted
it's-
it, send them an email.
trying to help them then figure out what they can do with that data. So I was telling them, I said, well, some of the articles I read, like, they use that data and they sell it to the law.
Go back. Yeah.
Oh, God.
That is one. Actually, he's like 10%. Three more classes.
So that's what I guess like real time, so under your management, you have real time data and you have predictive data. So the real time data in this case for everyone is tracking data in real time. So what's part of the experience? Oh. So a premier customer would be like a premium.
No, apply for commission. Yeah.
No,
No,
I think
no, the conferral or something. Where you got that?
That's, is it after we do? That would be after we do 815 and 816, right? After we do those last two core courses, which are the case studies. That's when we apply for the conferral, right? Like I know Big Brother.
Oh, how's your girlfriend's interview?
Oh, nice. Yo, you're gonna be awesome. Yo, my barber, he's Sean, his wife, is actually works in that company. He don't have Vegas, not in hand.
As long as I got the.
My barber, that's Johnny, somebody has that barber, he's probably everywhere.
Oh, yeah.
On the weekend, he's not in the barber, he's my
What,
dad,
Chris,
ass
that's what you're
talking.
doing?
His girlfriend
Everywhere.
got the job in Tulsa, right?
Ooh.
Oh, now you might have to met,
He ain't gonna marry her.
No, I don't understand.
You have to? Don't do it.
Jesus
Sorry.
Christ. You had that in you.
Don't do that, I'm not.
Hey, you never know.
Oh, okay.
I can just be like.
Yeah, her,
Travel buddy.
You don't wanna
Oh,
plug
okay.
it, you don't wanna go to
Because
jail
you can
and
take
see
your
it
friends,
come,
you can take anyone you want. On your plus one.
You can take buddy passes, but you have to pay.
sometimes you have to be married though.
No, you could do your spouse. Her mom and her dad will fly for free.
Mm-hmm.
And her significant other.
It's like, I'm not marrying for free tickets.
Oh.
We're not really, statistically speaking, 50%.
Listen, the standard error is huge. Suicidal rates.
Put that on your test.
Yeah, right. Jump with my test
So
results
when does
still.
she start? When does she have to go?
Just training in February.
In Atlanta? She went, that's their base. But in JetBlue's in Florida, Orlando. Yeah, she did hers
That would
there.
be nicer.
So is she going to, move and work somewhere else? My friend who works for Spirit, and he does places to places.
Well, just for training, she's gonna go take on a 2 month period.
But if she don't have the training, she don't get the job. You
Yeah.
know that, right? They eliminate people throughout the training process, because if you can't pass like the physical fitness cards and all that stuff, they kick you out, and you have to start all over. On their next training, yeah, it's very
Hard,
fast. A
12
lot
hours a
of
day.
people just leave because it's too much. And you have to be ready, like they teach you all the emergency things and all that stuff, and if you don't pass it, they only give you like one extra chance, and then that's it.
That would be fun.
So her home base, that base would be
Yeah, it's fun. That's what they're all running for Deadwood. Like, but you get more, no, but you pick up more flights. And then, one guy, we have like that buddy, yeah, that buddy thing, is kind of, agency, her friend sold his buddy pass to some, like, his buddy thing, so he put him as his person, and then I paid him like $3,000 a month, because he doesn't have to pay for it. And then I traveled like all the time, so he was wasting more money paying for flights, but then, like, so he's paid less by paying the guy for his buddy pass, and then to book flights all the time, so he, I mean, he was really up for that now. So he was like one of those crash pads?
Yeah.
They all
They all stay together, yeah.
And they all like crash together when they come home, when they have to fly out of that. Yeah, she did that because in the beginning, they didn't have any door, they didn't have spots, so she said it was the one that, back and forth.
Yeah.
Every time. So she could have had it probably over like a month, she would have to, every time she had a flight, she would have to fly from JFK to Boston to get on the plane in Boston to go to work.
Which is literally like a 25-minute flight.
So she had to take the plane to Boston, just to get on whatever plane was leaving from Boston to go.
I wouldn't say anything.
Because you couldn't find a crash pad.
That even happens sometimes when you wanna change it. Sometimes
Yeah.
it
You let it go, you go, like, oh, we're the line.
And I know one time,
It's a little
like,
plane.
No, the plane more people, 9 people.
American Airlines?
You said 9 people, the, seven of us. On this little thing, it was just that, it was 8 minutes, but like, that's how it was, but it was 30 minutes or 2 hours better.
Wait, Aaliyah died.
I swear, it was. They wait every single exhibition that was getting on the team. And I felt so bad.
Yeah, that's people.
They had to like book her like 2 seats. Because they couldn't put her with other people.
Yeah,
For like shoes. So they were like, plus her luggage, plus other people. It was like too much.
And you know you were okay with that.
Pilot features, pilot features.
Because they don't put Kylie on the plane, we don't
Need to wait.
freaking out. But I couldn't get started. So why you like, they like defend the airline for the that's
I go first with the fucking
yeah, like she's like, oh, please.
Ali, go ahead.
If it wasn't they work there, you wouldn't say all of that stuff.
no, I mean, it makes sense.
Plus, I get it, because they're like, if you don't fly the same way, the last day, we'll fly the right guy. So if you're doing something and you're disrupting, or the flight attendant feels uncomfortable, whatever, if she says you have to get off, you have to get off. The police don't want to take you off because she said you have to get off.
Now let me ask you this, is there a rule for
I don't think so. They just request them to cheat. It's usually like before the plane takes off and you're like,
25.
because they're like, anything can happen in there.
Supposedly there's always someone.
Well, there's a marshal thing that.
Yeah, a marshal, I think so. I think there's a
He's allowed to
marshal.
carry
There was a
gun
marshal
and
that
something,
one
but-
guy started arguing on the table over there and they had to take him off and my marshal came. The guy came, police came to take him off. It was a whole thing. Just get off the plane.
Front to back.
I just remember how airlines before used to give you rides, beans, meat,
all kind of stuff. Now they even have it soda with like 2 huge
Go
pies.
international.
You say what?
Take it international.
Oh, it's National Day.
Oh, like I'm
Wait a minute, I get nothing. Wait a minute. I go to the all the time, do I get like chips and soda? It's not international.
Overseas, they do.
Yeah,
I'll fight.
you go get chips. Not really anyway. It's like there. It's like You like whatever you want?
Alright, so let's go ahead and get started again. We spent some good time, or spent a lot of time, I don't know if it's good time or not, spent a lot of time discussing this multiple regression analysis. We looked at what we already knew, we talked about a few things we didn't know, which we're going to learn tonight. We estimated this regression equation, win-loss percentage could be predicted by field goal percentage and turnovers per game. Then we talked about this aspect of the independent variables, which predict the dependent variable, could possibly be related to each other, correlated to each other, and that's a problem we need to watch out for. And then we have because we have both of them in the same regression equation, we are controlling for one when we look at the other. So we're saying, if we hold turnovers per game constant, then each increase in field goal percentage would result in this much of an increase in win-loss percentage. So we might have avoided over-assigning or assigning too much merit to any of these independent variables by looking at them both together. Alright, so we have some performance measures in multiple regression analysis, most of which are pretty much exactly the same as simple regression analysis. Coefficient of multiple determination. This is the percentage of variation that can be explained by the regression equation. Exact same definition. Actually, I don't really hear people call it coefficient of multiple determination. I hear people just talk R squared. And when they talk about regression analysis, that's what you'll hear most often. So it's still the percentage of variation that can be explained. The square root of R squared is R. It's still going to be called the correlation coefficient. It's not going to be positive or negative because we're going to have multiple variables. One could be positive and the other could be negative. So we lose the ability to determine positive or negative relationship just by looking at this. If we want to know positive or negative, we look at the slope coefficients. Standard error of the estimates. Now this is still the average distance of each data point from the line of best fit or plane of best fit. Same definition, and I tell you what, it is calculated exactly the same way as we calculated it last week. Last week, we took the sum of squares error divided by n minus 2. This week, we're going to take the sum of squares error divided by n minus k minus 1. Alright, k is number of independent variables. What was it last week?
N minus 2.
It was n minus 1, but what were the number of independent variables last week?
1.
1. So last week we took n minus 1 minus 1, which is n minus 2. So we did this same equation last week. Now we're just adjusting it if we have more independent variables. So same thing. Adjusted R squared. This is an important one. This is a new performance measure. So remember I mentioned how if you put more independent variables into the equation, then the R squared will go up. Doesn't matter if they're just a tiny bit of correlation. They could be very, mostly unhelpful, but a tiny bit of help, and your R squared would just inch up and up and up. And so for that reason, you might be tempted to throw more and more independent variables in your model. And then you have 20, 30, 40 different variables you need to track, monitor, make sure that you have the right information, the right inputs. So you may not have a very good model, but your R squared keeps going up and up, and you look around and say, my R squared's better than yours. So we have another performance measure, adjusted R-squared, which penalizes you for adding more variables. So if you add more variables that don't help very much, adjusted R-squared goes down. And you can just see the math. K is number of independent variables. It's in a spot mathematically where if you add more K, this number will get bigger, which will make this number smaller, which make the total adjusted R-squared go down, unless that particular independent variable has a strong effect in explaining more of the variation. That's why we have the sum of squares error, sum of squares total in this equation. So you add more variables unnecessarily, adjusted R-squares goes down. So if you catch someone mouthing off about how great their R-squared is, ask them what their adjusted R-squared is. They'll be like, it doesn't adjust R-squared, doesn't matter. That's what they'll say. Alright, so those are performance measures. Now we're back to inference. Alright, how confident are we with taking this regression equation on the road and trying to sell it to a bunch of basketball coaches? Well, let's do a couple of tests. We know about t-tests. Those aren't always the best when we're looking at multiple regression, so we want the f-test. Let's do it. F-test. So f-test looks at the whole model and says, overall, how much explained variation do we have with this regression equation? How much of the variation can we explain? And how much of the variation can we not explain? So if, in reality, none of the slope coefficients, none of the independent variables have any predictive value, then the line of best fit, plane of best fit, that would just be a random line through data. And the chances are we would have the same amount of explained variation as we do unexplained variation. You with me there? If there's truly no relationship, if all the independent variables have slope coefficients of 0, then it would just be a random line of best fit, random plane of best fit through points of data randomly spread, and we would have the same amount of explained variation as we have unexplained variation. And so we take explained variation divided by unexplained variation, it would be 1. If there is no relationship anywhere in the model. You with me there? Alright, no relationship anywhere, explained and unexplained would be the same, this would be 1. Alright, so we need to see, does it equal 1 once we run the regression line? If we have a lot of explained variation and a little bit of unexplained variation, this is not 1, this becomes 5, 10, 20, some number greater than 1. And the higher the better. So that's the crux of it right there. We're going to do a hypothesis test which says there's no predictive ability anywhere. Both of these slope coefficients equal 0 in reality. I know you got in your sample of 23.6 and negative 4.069, but in reality, 0. Alright, that's the null hypothesis. Both of those equal 0. If that is true, then explained over unexplained for the whole model would equal 1. But if that's not true, then explained over unexplained would be a higher number, higher than 1. 5, 20, 40. So we're going to do a hypothesis test, and we're going to say if the null hypothesis is true, that there's no difference between explained variation and unexplained variation, there's no statistically significant relationship anywhere, then we would expect a F statistic of 1. It's a little bit more than 1, that's no big deal, this is random chance, it could be a little bit more than 1. A little bit less than 1, whatever. If it starts getting a lot more than 1, then what are we ready to do when it gets to this region here? What do you think this red thing is?
Reject.
Rejection region. We are going to reject a null hypothesis of no statistically significant relationship anywhere. And we're going to say, in fact, we do have a strong or significant correlation somewhere. Alright, null hypothesis for the F-test. The true population slope 1 and the true population slope 2 both equal 0. No statistical value, no predictive value, I should say. Anyway, alternative hypothesis is at least one of them is not 0. So we can explain at least some of the variation with one of these two. Our F-stat is 9.5, so that's bigger than 1. So just based on what we know so far, we think like, yeah, there's something valuable here, a statistically significant relationship somewhere. But you don't know 9, is that big enough? And I'm not going to teach you that because I don't think you need to know it. What I am going to teach you is this. This is the p-value for this F-stat. So, if this null hypothesis is true, alright, again, this null hypothesis says no statistically significant relationship anywhere, what are the chances that the F-stat explained over unexplained would be 9.5? What's the probability of that happening? Can someone tell me?
1.6%.
Yeah, 1 point,
0.0.
less than 1.6%. Yeah, 1/10 of 1%. About 1.5, a little more than, so about 2/10 of 1%. So would you consider that overwhelming evidence to reject this? Yeah? Yeah? Alright, that is highly unusual. Alright, so if this is true, and what does this mean? What's the null hypothesis say again?
Slope 1 and slope 2 is
The true population of the slope.
Are equal to 0. What does that mean that they're both equal to 0, Wendy? If they're both equal to 0, what does that mean?
No.
No predictive value,
No significance.
nothing we should go to the NCAA and try to make money off of. You could say we just wasted our time building this model. Alright, if both the true population slopes are 0, we have nothing that we can use to predict, explain, state cause and effect. So if that is true, then what are the chances that we would have 9.5 times as much explained as we do unexplained variation in this model? What are the chances that if there's truly no predictive value, that this would happen randomly? We would get a F-stat of 9.5. What are the chances of that happening?
16.
Chances of that happening? Ms. Porter.
Yeah, because of all people. Isn't the significance of F right over there?
Yeah. Yeah, what is it? What is it? Tell me.
0.00167
Yeah.
2
1/10 of 1%.
Right.
Alright, so what is your interpretation
Okay. Sorry.
then? Alright, okay. So the interpretation is that we reject this. Alright, because we've got results that are highly unusual if this is true. Results that are only 1/10 of 1% likely. So we look at that very low significance F, and we say we have something very significant. Because the p-value for the F-test is low. Yeah, this F significance is the p-value for the F-test.
And there's no significance at neighbor?
The null hypothesis is that there's no statistically significant relationship anywhere. That's the null. And Adamus, do we reject that or fail to reject that?
We'll reject that.
We reject that. Yes, the chances of this outcome is so unlikely. If that is true, we reject that. This is what we reject. I reject this null hypothesis. How are we feeling on that?
No.
Not feeling it, sort of feeling it? Right, okay.
I feel like I'm in turbo again.
Okay. Alright, well, the good news is that's pretty much all we need to know until we get to dummy variables. The rest is just kind of reviewed, what we talked about last class and this class. Well, let's soldier on then, right? Testing the statistical significance of the relationship. So in simple linear regression, both F and t-test lead to the same conclusion. In multiple regression, we need to use the F-test to determine whether a relationship exists between independent variables and the full set of independent variables. F-test tests overall significance. And then the t-test determines whether each of the individual independent variables is significant. F-test for the full set, t-test for individuals. Hypothesis is all the true population slopes equal 0. What does it mean if all the true population slopes equal 0? Keisha.
Say it again?
If all the true population slopes equal 0, what would that mean to you?
There's no relationship.
Yeah, there's no relationship anywhere. No useful relationship. Nothing that gives us predictive ability. Is that true? Well, we're going to assume it's true unless we have overwhelming evidence to the contrary. And if we get a really, really low F significance, p-value for the F, then we're going to reject that and assume that in fact there is something there. Our test statistic, if you will, is the F-stat. So we're going to, on this F distribution, we're going to plot an F statistic, and if it falls in here, we're going to say that would be extremely unlikely given everything equals 0. And we're going to say we reject that. I don't want you to concentrate on the critical value because I didn't teach you how to read the F table, but I just want you to concentrate on this p-value because that's something you might see again after this class. And it's intuitively exactly the same as the p-values for our previous weeks of hypothesis testing. Low p-value, reject the null. Feel free to interject questions. But I think you probably get it. If you're feeling shaky tonight or tomorrow, go back to this slide. What was he saying about the F-test? Oh, this is what it does. This is what it does. And this is how it's different from the t-test. And then this slide 25 summarizes how we frame the hypothesis test and concludes with reject the null hypothesis if the p-value is very small, lower than the significance level. This is just some review of the t-test coefficients. Remember how we do a hypothesis test for the t, or for the individual coefficients? Alright, this is like field goal percentage. We did a separate one for turnovers per game. Alright, we said how different is that from 0? How many standard errors different is that from 0? If it's a very large number, then we're going to reject the true population slope equals 0. We could use the critical value region, a way which you know how to use. Only difference between this week and last week is degrees of freedom is now n minus k minus 1. P-value approach is exactly the same as we've done in previous classes. Alright, this talks to a nuanced issue that has to do with multicollinearity. I've discussed that a little bit. I'm not going to discuss that too much more. This is the F-test results in our college sports example. We had a very high F-stat, which you can note that that's higher than 1. But the real thing I want you to note is the p-value is very low. So reject the null hypothesis.
Professor, just a clarification point, if the P, what would signify a high P value? Are we still looking at 0.5?
Yeah.
Okay, that's our threshold.
Yep. 0.5, or it could be 0.1, 0.01,
0.0,
5%, 1% are common significance levels.
okay.
Alright, what was this? Yeah, these were individual t-tests for our college sports examples. I think we did one of them, yeah, we did the 2.61, 2.617. Alright. And we rejected the no significant relationship null hypothesis for both of them, but it was close. Remember when we rejected the no significant null hypothesis for the individual t-test? It was really close. One was 1.8% and the other was 4.8%. But then when we look at the F test, was it close? The F test, the p-value, our threshold is 5% and the p-value is 1/10%. Is that close? That's not close at all, right? Alright, remember why I said why that might happen? Multicollinearity. Alright, multicollinearity is giving us hard to interpret results from the t-value, from the t-tests. Alright, so we see the F-test and we're like, man, that is a strong model. We see the t-test, we're like, I don't know, must be multicollinearity. Confidence intervals, you know how to do that. Alright, the actual slope coefficient of say 3.6 plus or minus some number of standard errors. How many standard errors use a t-table with n minus k minus 1 degrees of freedom? The only difference from previous weeks is now we're in minus k. Those are confidence intervals. Okay. Good. So dummy variables. Take a breath. Get a drink of water.
Give us a break.
Gosh. Alright, I'll remind you to take a breath. It's okay to breathe if I don't tell you to breathe.
Lisa, I gave you a break festival.
Alright. Let's see. What time are we at? 8:23, okay. Good. Alright. Anyone want to tell us a funny story from this weekend while we just refresh, absorb? Are you excited about hearing about Tom Brady's love for the game?
Oh my God, Tom, this is time. I just knew, I couldn't believe that they did that. I'm obsessed with Tom Brady, so I really know that's gonna be in my
Yeah.
life.
Yeah, we get to hear about that for another couple of weeks. Give me some time. The content for next week is fairly easy, so we should finish that maybe after about an hour and a half. And there'll be some time. There'll be some, yeah, as of now, it's scheduled to be 2 weeks from tonight in class.
Yeah.
Yeah, just
Plus his age.
you can bet any game, but just don't bet against school.
Don't bet against you?
Never.
Alright, we ready for dummy variables? Alright, so dummy variables are qualitative things. It's a yes or no type of answer. So you might say, does your basketball team have its own stadium? Yes or no? And if yes, you would increase or decrease the win-loss percentage by an estimated amount. What do you think? Does a team having its own stadium, would that increase or decrease your estimate for win-loss percentage? Yeah, I'd say increase. You have your own stadium, maybe the team has more money, they have better practice facilities, they have fans who come and are more consistent, they can distract the other team. You don't have to take the bus across town to borrow the high school gym. Alright, so that would be a dummy variable that would probably increase win-loss percentage. Other dummy variables, gender, male, female, that might increase, decrease your risk of heart disease.
Always think on that.
Let's take a look at an example. Alright, we've got a bunch of real estate data in Seattle, and we're going to try to predict the estimated sales price of homes. And we're going to use as our independent variables, first independent variable is square feet of that house. So if you have 200,000 square feet, you're going to put that into the regression equation, and that's going to be part of predicting the estimated sale price. The other dummy variable is going to be location. And we're going to have two locations. And for the first location, we're going to say, is this in location 1? Yes or no? If it is, we're going to put a 1 in that slope coefficient, that coefficient. If it isn't, we're going to put a 0. Then we're going to say location 2. Is this house in location 2? Yes or no? So we've got an example, or we did a simple random sample, good sampling techniques, of course, always. 20 homes. We have data on the selling price. And we looked back and we said, how many square feet did that house have? And we said, is it in location 90262? Yes or no? Is it in location 898199? Yes or no? And you can put that right in Excel. You can do dummy variables in Excel. And it's going to give you slope coefficients for these dummy variables. And it's just going to be a one-off. If it's in this zip code, add or subtract this amount to the estimated sales price. So we're going to get a predicted value for the sales price based on house size, if it is in this zip code, or if it is in this zip code. All right. Take a look at the Excel printout. Tell me what you know. I'll erase this, absorb, talk amongst yourselves for just a couple of minutes.